And the question is, how do we get these tightly collimated jets? They seem to be at least 10 times longer than they are wide.
It happens faster than anyone expects. Alerts cascade across observatories as tracking solutions update in real time. The object's position shifts again, closer, faster, deeper inside the inner solar system than predicted only hours earlier. 3I Atlas is no longer a distant anomaly on a chart. It is here, inside planetary space, moving on a trajectory that does not belong to the sun. Scientists do not debate what it is. They debate how much time is left. This is only the third confirmed interstellar object ever detected, and unlike the others, this one is arriving with speed that compresses every margin of error. There is no long approach, no rehearsal, no chance to catch it next orbit. Its path does not loop back. It does not slow down. It is passing through once, and the opportunity to understand it is evaporating by the hour. Within minutes, global coordination snaps into place. Optical telescopes refine its trajectory. Infrared sensors probe its surface temperature. Radar attempts bounce signals off a body that formed around another star. Under physics, no human instrument has ever directly tested. Early models begin to fail almost immediately. The brightness fluctuates too sharply. The motion does not settle. Calculations must be rewritten as the object crosses invisible thresholds where normal assumptions stop working. And then the realization spreads quietly through control rooms. 3I Atlas is already past the point where simulations can be trusted. It is too close, too fast, too foreign. That is when the Breakthrough Listen initiative escalates to full alert. Arrays around the world pivot in unison. Radio telescopes begin sweeping massive frequency ranges with unprecedented sensitivity. This is not a routine scan. This is a last chance sweep, searching not just for signals, but for the absence of them, searching for anything that does not behave the way a natural object should. Every second now carries weight. Every gap in the data is permanent. If 3I Atlas hides unusual physics, dormant activity, or something no one has predicted, it will not announce itself politely. It will appear once, briefly, inside a narrow observational window that is already closing. After that, it will be gone forever, carrying its answers back into interstellar darkness. As the first streams of raw data begin to pour in, analysts realize something else that tightens the tension even further. They are not just racing the object, they are racing their own instruments, their own assumptions, and the terrifying possibility that whatever matters most could already be slipping past them undetected. And just as the first scans finish processing, something unexpected begins to form inside the data, forcing scientists to stop everything and look closer. The alarm does not come from a sound. It comes from motion on a screen. Just days after discovery, the search tightens without mercy. At the Allen Telescope Array, dozens of dishes pivot in unison, locking onto 3I Atlas as it cuts through the inner solar system. Early July becomes a race against distance. The array begins sweeping the radio spectrum from 1 to 9 gigahertz with extreme sensitivity, far deeper than routine surveys. Scientists know the rule now. If anything artificial exists, it will not announce itself loudly, it will whisper. Then the data hits. Radio spectrograms flood the monitors, dense, chaotic, alive. Signals surge and slide instead of holding steady. Nothing sits where it should. Technicians lean closer as analysts slow the playback. In the noise, a pattern begins to form. A sharp diagonal streak cuts across the frequency time plot, clean and deliberate, unlike natural radio static. For a moment, the room goes still. Conversations stop mid-sentence. This is the shape they fear and crave at the same time. Everything halts. Could this be it? The streak is tracked frame by frame. Its slope suggests motion. Its persistence suggests intent. The possibility hangs in the air, heavy and electric. If confirmed, this would not be debris. It would not be chemistry. It would be something engineered, something transmitting while passing silently through planetary space. The implication hits instantly. This would mean we were not just observing an interstellar object, we were intercepting activity. Then the twist lands. The same streak appears again. Not where 3i Atlas should be, but in off-target scans, controlled data, empty sky. The realization cuts fast and cold: human interference. A terrestrial signal bleeding into the array. The verdict is swift and final: rejected. Relief ripples through the room, but it does not last, because relief is followed by something worse. If that signal fooled them once, how many others had already slipped past? If interference could imitate something extraordinary, then something extraordinary could just as easily hide inside what looks ordinary. The room fills again with noise, not from the machines, but from thought. Scientists exchange looks without speaking. A real signal would not behave like a beacon. It would not repeat. It would not sit neatly in a single frequency band. It would adapt. It would be quiet. It would know how to disappear. And that realization sharpens the fear. No detection does not mean nothing is there. It only means nothing obvious is there. Silence is no longer comforting. It is suspicious. The absence of evidence becomes its own data point, logged with care and unease. If something is riding with 3i Atlas, dormant or shielded, this is exactly how it would look. The hunt does not slow. It deepens. Filters are rewritten. Thresholds lowered. Assumptions stripped away one by one. Every faint anomaly is flagged. Every false positive becomes a lesson. The object continues moving, indifferent to the scrutiny, carrying its secrets with it as it races toward a window that will never open again. And as the Allen telescope array keeps listening, scientists confront the most unsettling question yet. What if the real signal is not the one that stands out, but the one that blends in perfectly? The search is no longer about finding proof. It is about realizing how easily it could be missed. And just as the team adjusts their methods, another facility prepares to take over the chase, one that will look not for signals, but for chemistry, for substance, for something breaking apart under sunlight. The warning shifts hemispheres without losing momentum. In the southern skies, alarms trigger as Meerkat begins its sweep, and the story takes a sharp, chemical turn. Almost immediately, new signatures flare into view. Hydroxyl radicals appear, clear fingerprints of water ice being violently torn apart by sunlight. This is not a quiet release. It is explosive, unstable, and faster than expected for an object that should be cold, aged, and inert after traveling between stars for millions of years. At first glance, the behavior fits a comet, but only just. The outgassing pattern is uneven. The timing is off. The plume geometry refuses to settle into familiar models. Researchers notice that the hydroxyl signal surges in bursts, not smoothly, as if fresh material is being exposed in stages. Something is cracking, peeling, or activating beneath the surface. No one says it out loud, but the thought spreads anyway. Interstellar objects were never tested this close to a star before. At the same time, far from the dishes in South Africa, Breakthrough Listen's computing systems are running at their absolute limit. Algorithms dig deeper than ever before, pushing sensitivity to levels comparable to detecting a mobile phone signal from another star system. This is the quietest search humanity has ever conducted. If anything artificial speaks, even whispers, it should appear now. Nothing does. And that absence hits harder than any detection, because silence at this sensitivity is no longer neutral. A dormant probe would be silent. A shielded system would be silent. A device waiting for the right conditions would be silent. The data refuses to rule anything out. Instead, it tightens the trap. The lack of signal becomes a measurement. The nothingness is cataloged, time-stamped, and fed back into the models as a variable instead of a conclusion. Scientists exchange uneasy glances as trajectories update again. 3I Atlas is accelerating away from certainty, its chemistry changing under solar stress, its radio profile flat and unreadable. Each second it moves farther from the assumptions that once felt safe. The object is behaving naturally, just not comfortably so. And as Meerkat keeps listening, as the hydroxyl glow flickers and fades, one question hangs unresolved in the control rooms. If this is only the beginning of what sunlight reveals, what happens when the next instrument looks even closer? The shock lands without warning. Optical systems suddenly flood with alerts as visible and infrared eyes lock on at once. The comet's ejecta is no longer a faint blur, it is exploding outward in real time. Cameras catch filaments tearing away from the nucleus faster than models predict, as if the surface is shedding layers under invisible stress. Analysts tense instantly. This is the first moment where light, not radio, takes control of the chase. There is no margin for delay. Every frame could be the last clean look before the geometry breaks apart. The Vera C. Rubin Observatory tracks the plume with ruthless precision. Its sensors search for the impossible, pinpoint laser flashes, sharp-edged bursts, anything that would not blur like dust or gas. Nothing appears, no artificial spike, no clean pulse. On paper, that should end the question. Instead, the unease deepens, because while the light shows nothing unnatural, the behavior does not settle down. The chemistry refuses to behave. Infrared analysis reveals rapid shifts in ejecta composition, changing faster than solar heating alone can explain. Ice fragments vaporize unevenly. Jets flicker on and off without pattern. The plume reshapes itself between exposures, not gradually, but abruptly, like something destabilizing from within. Scientists cross-check timestamps, fearing instrument error. The data holds. The comet is not breaking apart, but it is not stable either. Each non-detection sharpens the paradox. Nothing artificial is seen. Nothing artificial is heard. Yet the object reacts as though it is passing through environments it was never designed for. Interstellar material, forged around another star, is now colliding with solar radiation it has never experienced before. The sun is not just illuminating it, it is testing it. And the response is faster, sharper, more volatile than expected. That realization changes the tone inside control rooms. This is no longer about finding aliens or signals. That question quietly collapses. A more uncomfortable truth takes its place. Interstellar space is not empty, it is active. It produces objects strong enough to survive star systems, fast enough to slip past detection, and fragile enough to behave unpredictably once exposed. The solar system is not sealed, it is porous. Scientists feel the shift as it happens. Models that once treated interstellar visitors as rare curiosities now look incomplete. If this object can cross the sun's domain unnoticed until the last moment, then others could have done the same. Some may already have passed through, some may not have left clear signatures. The danger is not invasion, it is blindness. As ejecta continues to morph and accelerate, observers realize something unsettling. Optical silence does not mean safety, it means limits. Limits of detection, limits of expectation, limits of preparedness. And while the light shows nothing artificial, the clock keeps ticking. Because the closer 3I Atlas moves, the fewer chances remain to understand what these behaviors mean, and the next phase of observation is about to push sensitivity to a level humanity has never reached before. The warning intensifies without ceremony. 3I Atlas is no longer distant background noise. It is now close enough to force uncomfortable precision. In Australia, the Parkes radio telescope locks on during multiple passes, each one tighter, each one more unforgiving than the last. the margins vanish. At this range, even a weak transmission, no stronger than a household light bulb, would pierce the data. Scientists understand what this means. There is no longer room for hiding behind sensitivity limits. If anything is there, it will have to reveal itself now. The observations stretch for hours at a time. Engineers push the receivers to their limits, stripping away interference, isolating narrow-band spikes, hunting for patterns that nature struggles to produce. Every sweep returns the same verdict: silence. But it is not a comforting silence. It is sharp, deliberate, and unresolved. The narrow-band analysis, the most revealing layer of all, is still processing. The most important data remains unfinished, suspended in computation as the clock keeps moving forward. This is where the tension peaks. Scientists know they are standing at the edge of a one-time window. As 3I Atlas closes in, signal strength briefly reaches its maximum. Then it will fall off rapidly, collapsing as the object speeds past Earth's neighborhood and back into deep space. There will be no rewind. No second chance. Observatories around the world coordinate their schedules with near-military urgency. Miss this moment and whatever the object carries, natural or not, vanishes forever. What unsettles researchers most is not what they see, but what they don't. The object remains radio quiet even as sensitivity reaches levels never before applied to an interstellar visitor. If it is emitting, it is doing so below expectations. If it is silent, the silence itself raises questions. Dormant systems, directional emissions, shielded structures. None can be ruled out, and none can be confirmed. The data refuses to settle into certainty. As the final passes approach, the atmosphere inside control rooms shifts. This is no longer routine observation, it is a countdown. Every second that passes reduces the odds of discovery. Every clean scan tightens the mystery instead of resolving it. Scientists understand the brutal truth forming beneath the numbers. Whatever secrets 3I Atlas holds must surface now, at peak proximity, or they will disappear into interstellar darkness before anyone can decide what they truly meant. And as the last Parkes observations conclude, attention quietly turns to the next phase, the final listen, the most sensitive ears humanity has. What comes next will not allow ambiguity. Either the silence breaks or it becomes permanent. The moment hits without mercy. In the final hours before closest approach, alarms ripple through control rooms as fresh trajectory updates confirm there will be no second chance. On December 18th, the Green Bank telescope turns fully toward 3Y Atlas, locking on as the interstellar object slices past Earth's neighborhood at unforgiving speed. This is not routine observation. This is the deepest radio interrogation humanity has ever aimed at something born around another star. Frequencies from 1 to 12 gigahertz are swept again and again, tighter each time, pushing sensitivity to a chilling threshold. Signals as weak as 0.1 watts would stand out. A transmitter weaker than a household nightlight could not hide. If anything artificial exists, this is the moment it must speak. Inside the data stream, tension rises second by second. Spectrograms scroll in real time, dense with noise that refuses to settle. Analysts lean forward as narrow-band filters carve through the static, stripping away Earth-based interference, satellites, aircraft, everything human. What remains should be silence or revelation. For long stretches, the signal floor holds steady, too steady. Then small fluctuations appear, barely above the noise, just enough to force a pause. The room freezes. Are these thermal artifacts? Instrument drift? Or something reacting to proximity, something waking as the sun's gravity peaks? No one says it out loud, but everyone feels it. This is the closest humanity has ever been to overhearing an alien visitor without it knowing it is being listened to. The verdict arrives like a blunt impact. No confirmed artificial radio emission, no repeating beacon, no engineered signal. The official classification locks in: natural object. A line is drawn through months of anticipation with a single word, yet relief does not spread the way it should. Instead, a heavier silence settles in, because the absence itself refuses to behave normally. At this distance, even accidental leakage, an unshielded oscillator, a malfunctioning transmitter, a dying probe should have betrayed itself. Nothing does. The silence is clean, deliberate, and that unsettles the scientists more than any false alarm ever could. As Earth rotates away and the observation window collapses, the implications sharpen. By the time deeper analysis finishes, by the time every last algorithm rechecks the data, 3i Atlas will already be gone, accelerating back into interstellar darkness, unreachable, unrepeatable. Whatever internal structure it carries, whatever history shaped it, whatever secrets it held during this one narrow pass, they are leaving with it. What remains behind is not confirmation, but vulnerability. Proof that objects from other stars can cross the heart of our system with almost no warning. Proof that silence does not equal harmlessness. And as the telescope powers down, one question refuses to fade. When the next interstellar visitor arrives, will we recognize its importance before it slips past us, or only after it's already too late?